All right, guys. So to review the past few days, we've been learning about binomial distribution. So in a binomial distribution, there are four conditions. As you can see here, there are a fixed number of trials. There are only two outcomes of interest, success and failure. Each trial is independent, and the random variable x counts the number of successes. So today we will be going over a different type of distribution. Today we will be going over the geometric distribution. So in a geometric distribution, there are also a few conditions that need to be met. So the first condition is the experiment is repeated until a success occurs. So this means that, for example, if I am flipping a coin and I define my success as getting a heads, I will keep flipping the coin until I get a heads. So in this case, for a binomial distribution, I would already tell you that I will flip the coins this amount of times. For a geometric distribution, we do not know how many times the coin will be flipped. It could be the success happens on the first trial. It could be that there is no successes until the 10th trial. So in this case, the number of trials that will happen is not fixed. The second condition, the probability of success for each trial is the same, independent. So this condition is the same as the binomial distribution condition. Each trial is independent of each other. That means that if I do something the first time, it should not affect the probability of it happening the second time. The third condition is the random variable x represents when the success happens. In this case, let's say again with the coin flip example, if I succeed on my first try, then x would be equal to 1. If I succeed on my 10th trial, then x would be equal to 10, and so on. The formula to calculate what the probability is for the first success to happen on x amount of trials is P, probability of success happening at x, is equal to P times Q to the power of x minus 1. So P times Q to the power of x minus 1. This is a much simpler formula compared to binomial, but also the conditions are much more strict. So what do these numbers mean? P and Q are similar to what we have already learned. P is the probability of success. Meanwhile, Q is the probability of failure. And X, as we stated above, it represents when the success happens. Represents when the success happens. So there's only three variables involved. P and Q are usually given either in percentage form or in decimal form. Sometimes if it's a dice or cards or coins or marbles, you would have to calculate the probability by yourself. So in order to see how this works, we're going to go through a few examples. So in this example, a 12-sided dice is rolled, the die is rolled until a number higher than 8 appears. So in this case, our probability of success, and here our success is that if we get a number higher than 8, is 3 out of 12, right? There are 3 numbers higher than 8, 9, 10, 11. Oh, sorry, there's 4 numbers higher than 8, 9, 10, 11, 12. So 4 out of 12, which is equal to 1/3, or about 0.33. Q on the other side would be the opposite of that. So 1 minus 0.33, or equal to 0.67. You could also do, on the other side, 8 divided by 12, which is 2/3, which is also 0.67. So either way, Q would be equal to 0.67. So now let's do some of these questions. So the first question is, what is the probability that the first time a number higher than 8 appears is the 5th roll? So in this question, my x is equal to 5, right? It specifically tells me that it is the 5th roll. So then our probability is equal to 0.33 times 0.67 to the power of 5 minus 1, or to the power of 4, right? So I will go ahead and do that on a calculator. 0.33 times 0.67 to the power of 4 equals 0.066. So equals 0.066, or about approximately 6.7%. So this is the basic formula. You got your variables, P, Q, X. You substitute it in for the equation, and you can get your answer. Next up, it's asking for a number higher than 8 that appears within the first 4 rolls. So in this case, the first 4 rolls implies that we have to add up a few numbers, right? In this case, within the first 4 rolls includes the number 4, right? 1, 2, 3, 4 are within 4 rolls. So that means that we need to do 1, 2, 3, 4 calculations in order to get the sum. So I'll start with 1, which is 0.33 times 0.67 to the power of 1 minus 1, which is 0. Anything to the power of 0 is 1. So for 1, it is simply equal to 0.33. Next one, 0.33 times 0.67 to the power of 2 minus 1, which is just 1, which gives me 0.33 times 0.67, 0.2211. Next equation, 0.67 to the power of 3 minus 1, which is 2, which gives me 0.67 to the power of 2 times 0.33, 0.148 approximately. Next up, for 4, 0.33 times 0.67 to the power of 3, because 3 is 4 minus 1. So 0.67 to the power of 3 times 0.33, 0.099. So now we can add up all these probabilities. 0.33 plus 0.221. I'll just do 3 decimal places, plus 0.148 plus 0.099. This gives us 8 plus 0.099 gives me 0.798. So the probability that a number higher than 8 will be in the first 4 rows is about 79.8%. The final question is asking, what is the probability that it takes at least 3 rolls? In this case, at least 3 rolls means that it's a number bigger than 3, right? So it has to be 3 or bigger. So it has to be 3, 4, 5, 6, 7, 8, 9, and it actually goes all the way to infinity. Now, we don't have the resources to calculate all of those probabilities to add them up, right? But what we do know is that if we add up all of our probabilities, it must be equal to 1. If you're using decimal form, it will be equal to 1. If you're writing these in percent, it would be equal to 100%, right? So in this case, we can actually do some subtraction, right? If it will take at least 3 rolls, then that means that it is not in the first 2 rolls, right? So that means that we can do 1 minus this and then minus this. So 1 minus 0.33 minus 0.221. 221, which gives us 0.449, or about 44.9%. So the probability that it will take at least 3 rolls to get a number higher than 8 is about 45%, so a little bit less than half. So overall, this is basically all you need to do for your homework. Be careful with the wording of within and at least. Those are the ones that you will need to deal with for this homework. The other thing to be careful about is your scientific notation, especially for 10 to the power of negative 3, 10 to the power of negative 4, 10 to the power of negative 5. Make sure that the amount of zeros in front is correct when you do your addition. Otherwise, it might come out differently from the correct answer. I will account for some rounding issues. For example, instead of 44.9, if you answered 43 or 45 or 46, those are all in the realm of possible correct answers, and so I will accept those answers too. With that being said, that is pretty much everything about geometric distribution that you need to know. If you have any questions, just email me or talk to me in class tomorrow.